Let's first discuss what is numpy. The numpy library is the core library for scientific computing in Python. It provides a high performance multi-dimensional array object and tools for working with these arrays. The key to numpy is ND array object and n-dimensional array of homogeneous data types, with many operations being performed in compiled code for performance. Like down there is image 0, 1, 2, 3, 4, 5, 6, 7, 8. This is like single element of data type D type. That's called D type. Like numpy is a library in Python which is for numbers and a multi-dimensional array object tools which work with arrays. There are several important differences between numpy arrays and the standard Python sequences. Like there are lots of differences between numpy and numpy arrays and standard Python sequences. Numpy arrays, they are like numpy arrays are have fixed size. Modifying the size means creating a new array. Like in numpy arrays, there is a fixed size. If you want to modify that array, it's like creating a size. It's like creating a new array. Numpy arrays must be of same data type, but then this can be included Python objects. Like numpy arrays should have same data types like integer data type or float or string data type. More efficient mathematical operations than built-in sequence types. Like now these are the the differences, main differences. Like they are different have fixed size numpy library, and need to be same of data types and more efficient mathematical operations than built-in sequence types. Import numpy as np. Like let's take a is equals to, it's stored in a list 1 2 3 4 5 6, print a type a. The output is like type is it's like list, and the print is what's there in the list, it will be printed. A is equals to np dot array of a, print a type a. Like same, this is of type a, this is an example, let's see that. Print a np array, that the output is both of same type, and the down one is of numpy library and the up one is just normal one. Print np dot endime a. Answer, what answer, let's check. Print np dot shape rows, np dot shape a of list 0, columns np dot shape a of 1, print number of rows columns, print number of columns. So output is number of rows is equals to 2, number of columns is 3. See the answer, print np dot endime of a, answer is 2, and np dot shape of a is answer is 3. Now import numpy as numpy. It's like 0 1 2 3 4. A is equals to n dot p, arrange 15, reshape means we need to shape it really, reshape 3 5. The answer, let's check what's the answer. Next, print a, there is something, print a dot endime, print a dot shape, print a dot data type name, print a dot item size, print a dot size, b is equals to nb array 6. In list it's stored like 6 7 8, print b and print what is the type of b. See the answer, b is numpy dot nd array, because b is stored in np array. Like same, a is also stored in np and array, but now let's see a, print a, the a is like this is the answer, print a shape 3 item size is into 64. Array creation, how to create array. A is equals to np dot array of list 2 3 4, print a, what will be printed, it's like list will be printed 2 there will be no comma 2 3 4. A d type means what is the type, a d type means what is data type, d type int 64. It's no next b, the up one we took it in flow integer data type, but in numpy we can't take integer and float data type in same array. That's the point. So that's why only in A we just took integer data type. In the next example, we'll take a floating point data type and see what will be the answer. Now let's take an example. The example is b is equals to np dot array of the points were in the list are 1.2 and 3.5 and 5.1. Print b. The list will be printed, and b dot d type means what's the data type of b? It's floating point, float 64. Right. Now array transforms sequences of sequences into two-dimensional arrays. Sequence of sequences into three-dimensional arrays, and so on. Now again another example, b is equals to num array. We took a data type, a list. In that, in one call brackets we took a floating point and an integer. In the other one we just took integer. What will be print? See, that's the b. 1.5, 2 and 3, 4, 5, 6. The type of arrays can also be explicit specified at creation time. Like c is equals to numpy, an example array. Brackets 1, 2 is there in 3, 4. D is equals to, like D type we are taking it a complex one this time. Like we want complex number, complex way. So we took it in we want it in a complex way. So we are specifying it like we want complex type. So if we print C, we'll be getting C. 1 plus 0 I 0 dot j, because 1 is a complex number but if it doesn't have an imaginary root, that's why 0 dot j. Same as 2 plus 0 dot j, 0 into j, 3 plus 0 into j, 4 plus 0 into j. The output is like it's in complex numbers. Now again, and the next example, c is equals to np dot array. Np is like numpy, we are using it. It's in next array, and the list in that array we have a list containing numbers from 1 to 10. We want to print c. The print c will be printed like all the numbers excluding the commas will be excluded and list will be printed. D, we took another variable d, and in numpy we are reshaping it like c comma 2 comma 5, like print d. If you print d, what's the answer? 1 2 3 4 5, and see in it's like we are taking it in two parts and the numbers were 5 it were divided. That's why you got 5 numbers in one and 5 in other one. The elements of an array are originally unknown. Like the elements of array originally unknown, but its sign is known. Its numpy offers several functions to create arrays with initial placeholder content. These minimize the necessary of growing arrays and expensive operation. Like the elements of arrays are unknown originally, but its size is known. That's why numpy offers several functions to create arrays with initial placeholder content. This minimizes the necessity of growing arrays, an expensive operation. The function zeros create an array full of zeros. Like if function is of zeros, it creates an array full of zeros. The function 1 creates arrays full of ones, same as usual as 1. And the function empty creates an array whose initial content is random and depends on the state of the memory. But default the d type means data type of the created array is float 64. Okay, now let's take an example. Now print in numpy the zeros of 3 comma 4. So we are printing 3 lists in which 4 are divided. See the answer. In the main list, the list we are taking a list. In that sublists are 3. In sublist we need 4 numbers which are zeros. Like that's the point, right? Now same with the down example, print numpy ones. We want all ones in which 2 lists, one list in that another list, in that 3 were divided and 4 for need to be there in that list. D type, numpy int 16. The data type is np and np in numpy integer 16. So that's the answer sheet. 3 in one list, in that another list, in that list we need 3 lists, in which in that list we need 4 ones in every list. Same like now last example in this space slide, it's print numpy.empty. Numpy is written in the short form of np. Empty means we can print any variable. Can print any variable, any number, but we need 2 points in that. 2 which are divided in that we need 3 points. So that's they printed like 1.3906 so on something on the blah blah blah. It will be printed like that because it's empty. Nothing is there that can take any value. It's not a specific value. To create sequences of numbers, numpy provides a function analogs to range that returns array instead of list. np.arrange 10, 30, 5. It's like 10 is taken first with a space of 5 numbers. It need to be printed until 30. Before 30, what's the number which is divisible by 5? So the answer is 10 and 15 and 20 and 25, which are in the range 10 to 30, but 30 excluded. Why we took 5? Because the range of 5, because it was given in the np arrange 10, 30, 5. Now np arrange 0, 2, 3.6. So first we take 0, after the 0.6, after the 0.9, after the 1.2, 1.5, 1.8, but 2 need to be excluded. Now we know got it right. Like we need to multiply with 0.3 every time, from add 0.3 every time. Here at the same 10, after 10 we need to add 5 until a number which is below 30 is displayed, or the result need to be less than 30, and it should start from 10. In the above case, in the below case, we need to be started from 0. When arrange is used with floating point arguments, what is arrange and it's given there. Floating point arguments, it is generally not possible to predict the number of elements obtained due to finite floating point restrictions. Yeah, like floating point, it has lots of numbers, right? For this reason, it's usually better to use a function line space that receives as an argument the number of elements we want. Like we arrange when like in the second example after 10, when we arrange in used. For this reason, it is usually better. Like it's better to use a function line space that receives and as an argument that the number of elements that we want. Now let's write a program and let's see what's the answer. The answer is not displayed, so from this what will be the answer? Let's predict. From numpy import pi. Like from numpy library we need to import pi, print np is the short form of numpy, line space 0, 2, 9. X is equals to np dot line space 0, 2 into pi, 100. Print x. F is equals to np dot sin x, print f. Let's see what the answer. Now basic operations, arithmetic operations on arrays. Apply element wise. A new array is created and filled with result. Like we have, this is like to add or subtract, basic operations like add, multiplication, division, power, side value, cost value, and so on. So a new like arithmetic operators on arrays apply element wise. Like take few elements like 15, 20. It absolutely like 15, then 20, then 30, next, so on. A new array is created and filled with the result, and after that a new array is created and it will be filled with the results. Now a is equals to np dot array and a list is taken which contains 20, 30, 40 and 50, and we need to print A. What is A? Another program, B is equals to np dot arrange, only 4 is there, print B. Now A and B are taken, we need to print C. A C variable is taken, we need to know A minus B. A is an array which contains list, B is arrange 4. We need to print C, which is a variable, which is the value is A minus B, print C. Likewise, the next one is print B raised to the power of 10. The next one, print 10 into np dot sign of A, the value which you get in A into sign into A. Print A is less than 30. Unlike in many matrices, the product operator operates element wise in numpy arrays. The matrix product can be performed using the operator in Python greater than or equal to 3.5 or dot function or a method. Now let's take A is equals to np dot array, which contains a list. In that, another list is there of two elements 1, 1 and 0, 1. Then print A will get 1, 1, 1, 1 and 0, 1. Print A, that stands B. np dot array, which contains a list. In that we have two lists which contain, in each list we have two elements 2, 0 and 3, 4. Print B. Print the element wise product. Like we need product element wise. From A we need to take one element, B need to take another element and do product of those. Print A into B. Print the matrix product A thread B. In this numpy, to find the matrix product we need to use a thread operator. Then print the matrix product using dot function A dot B. Matrix product can be found two ways, like in numpy, which is a thread and dot functions. A is equals to np array, and array in that one list is there. B is equals to np array. In that, in a list there are two types, two tuples in the data type float, and the data type is float. Okay, C is equals to np array. In that we have float and integer data type float. Print 1d A, and we need A, the 1d is print 2d B, 3d C. D, np arrange 10, 25, 5. Print D is equals to np dot full of 2, 2, 7. Print the full array. Print E, F is equals to np dot I of 3. Print the 3 into 3 identity matrix. Print F. Print the random array. Print np dot random 2, 2. Print the subtraction of A, B. A and B. Print np subtract A, B. Similarly, try. We can also try comparison operators and so on, and add, divide, multiply, exponent, square root, sine of that, cos of that, log and tan, and so on. Lots of functions are there. Then aggregate functions. Print b dot sum. Print np dot sum of b. Similarly, try sum, minimum, maximum, mean, median, mode, and stand, std, num dot std. In that there were like tables are there, figures are there, we can check out that. So we need to try. Now copying arrays. How to copy an array? H is equals to A dot weave and print H. C is equals to np dot copy of B, print C. Now H is equals to A dot copy, print H. Sorting arrays. B is equals to np dot array, and in that we have a list which contains numbers. Print B. Print np dot sort of B, A of sort, C of sort of x axis to 0. Subsetting. A is equals to np dot array of 1, 2, 3, a list, B of which contains list of float. The numbers are given there, A of 2, 3 and figures are also placed there. It is called subsetting. A is equals to an array is given, in that a list was given. In B that also the list was given, but it is of a floating point. Slicing is also there. How to slice it? Same as Python. Indexing also is there. B of C. Now transposing. I is equals to np dot transpose of B, print I. I dot t changing an array. B dot travel flatten the array. G dot reshape